Systems thinkers use modelling to understand a complex system or problem from different perspectives and to use models to understand and create solutions to those problems. One of those problems is testing. In the last video, we looked at what a system was, a group of interacting, interrelated, independent parts, and so on. If we map that to our experience as testers in a systems context, we test systems that are built from software components, which themselves are complex. They are integrated into subsystems, and those systems integrate with other systems. And ultimately, we have a user or a business community that make use of those systems, and they operate within a business context, and so on. It goes on. The system as a whole that we're testing involves the technologies, the data, the people, the business processes, and so on. When I say that testing is really systems thinking, this is what I'm getting at, in that we have to analyse and break down these complex systems of systems to understand what to do next as testers. Now, systems thinking is just a way of looking at the world through different points of view. Now, by that I mean that we have to look through the eyes of the end user, we have to look through the eyes of technical architects, we have to look through the eyes of users with respect to usability, but also what they want from systems to do their job or achieve their low-level or very high-level business goals. So we test from the perspective of stakeholders, but we also test from the perspective of the technology situation. We look at the patterns of use, the user journeys, for example, and we also look at the patterns of failure, the risks of failure, of course. Now, we also look at other perspectives from time to time when they're necessary. So it's quite a difficult job that we have on our hands. So we have to manage this complexity and understand this complexity in some way, in a systematic way, in a systems thinking way. We use systems thinking to model the complexity of the systems we deal with through different points of view, from different perspectives. So let's just look at perspectives with a kind of an example. Suppose we create a thought experiment of giving a task to some individuals, and we ask them to use a barometer to measure the height of a church tower. So the barometer is an anaerobic barometer, if that means anything to you. So let's say we asked several people, and here are their responses to how they would solve this problem. The physicists would take the barometer to the top of the tower and measure the air pressure, and at the bottom of the tower and measure the air pressure again, and look at the difference in air pressure and use that to calculate the height of the tower. The engineer, being a more pragmatic type, might say, let's drop the barometer off the top of the tower, time its descent, and use that time to work out the height of the tower. An architect might tie the barometer to a piece of string and lower the barometer from the top of the tower to the ground, and then measure the length of string that they've handed out, and that would be the height of the tower. A surveyor might look at using the sun and the shadows cast by the tower and the barometer, and using geometry calculate the height of the tower proportional to the height of the barometer. The marketer might suggest, let's go to the priest, ask them what the height of the tower is, and promise to give them the barometer if they tell them the story. So there's more than one way to view any situation. There's more than one way to view any problem. Now, as testers, we're often, and perhaps always, dealing with people in different viewpoints of the situation, of the system under test, of the requirements for the system under test. Now, these people see problems and the solutions, the requirements, and what the functionality of a system will be. They see these things differently. This is very common. So we have to deal with contradictions and the fallibility of our knowledge. So remember Socrates, I mentioned in the first talk in this series, that he discovered that different words mean different things to different people. It's the same with complex situations and problems and context. People think differently and they actually see things differently because of their different experience, skills, prejudices, biases, and so on and so on. It's a complex problem to solve. So systems thinking helps us to understand complex systems. Systems thinking involves looking at the interconnections between parts, components, subsystems, business processes, people's usage patterns, rather than concentrate just on the parts. So we look at testing the parts, the components, the subsystems, but we also look at things in the round, the overall system, as a means of achieving some business goal or objective. And we look at these connections between parts and this interaction between different parts of our system from different perspectives. It's critical. Now, it's been called joined up thinking, that systems thinking is joined up thinking, but really it's just looking at things from different point of view and making the connections between people, their knowledge and skills, the business goal, the technologies, the data, the interfaces. We're just looking at things in a more holistic way to understand the complexity and then to figure out how best to test that system in its own way. Peter Senge wrote a quite famous book called The Fifth Discipline, and he made this statement. In the long run, the sustainable competitive advantage is your organisation's ability to learn faster than the competition. And he was looking at organisational capability and organisational learning. And if you like, he focused on four aspects of this idea of personal mastery, which is an individual's capabilities, mental models, which all people make use of, whether they write them down or not. There's team learning, to do with how teams as teams make progress in their learning and progress in change, essentially. And obviously a shared vision that has to come from the leadership of an organisation. Now, systems thinking is a way of looking at all these kind of complex contributors to making progress in organisational change. So systems thinking isn't just about technical issues. It's a global, universal approach to thinking through problem solving. Now, Daniel Kim came up with a slightly softer view of systems thinking. And by softer, I mean it's a more humanistic way of looking at things. And he says this, a way of seeing and talking about reality that helps us better understand and work with systems to influence the quality of our lives. So essentially, what systems thinking is taking a different point of view to gather information, to understand complexity from different angles, to learn to gather information from those different angles, and perhaps to come up with solutions that are novel and innovative in that respect. Richard Feynman, a hero of mine, famously took the view that the way to solve problems in physics, and coming up with theories in physics, was to look at things from different points of view. And he came up with different approaches to almost everybody in all his peers. He came up with solutions to problems other people just found impossible to understand because he came at things from weird angles. Now, if you like, the problem of coming up with a theory of nature and ultimately a mathematical formulation, these are models of nature, models of reality. So if you like, the way a physicist thinks, a theoretical physicist thinks, in terms of how to look at different viewpoints of the world and coming up with a theory which is then demonstrably matching reality through experiment. This is kind of close to what we do as testing. We come up with a theory of how a system should work. We use that theory, that model, to derive tests which will provide evidence of the system working or not working. And then we share that evidence with people who are going to make a decision on the back of it. Now, in some ways, you could call science a branch of systems thinking. That's a kind of a very idealized view of the world. But I think it's reasonable to say that the scientific method, that is looking at nature, coming up with theories, using evidence to prove or disprove those theories and adopt or adapt them depending on that evidence, this is very similar to how we think about what testing does when we provide evidence of systems doing what they should do or perhaps not doing what they should do. Now, this idea of systems thinking and the models that we create, you could also look at them as a vocabulary or language to describe systemic behaviour. If you think about how we construct and build our understanding of what a system should do, we might jot down flowcharts or collaboration diagrams or swim lanes diagrams or logic models or whatever. All these things are models. They all represent a different perspective of the behaviour of the systems that we test. And the perspective might be at a very low level, looking at the flow through code, through software itself, or it might be at a very high level, looking at the movement of data across multiple systems in a very large organisation or a global corporation. So at all these levels, we use mental models, perhaps we write them down sometimes, to describe behaviour of our systems. So system thinking is really a range of techniques and devices for usually visually capturing and communicating information about systems. Because what we use our models to do is to get a common understanding, to almost demonstrate, have I understood your requirements? And here's my model that gives you my understanding. Is this appropriate? Is this accurate? And that's kind of the game we're in. We use models to communicate as much as to do the technical stuff to create tests. Systems thinking is just a set of tools, a set of thinking tools primarily. Now, some of the key components of system thinking are these concepts of boundary or scope, and of course testers have to deal with understanding the scope of testing. We have to deal with environment, context, and of course the context affects how the system behaves, but also what we need to do in order to demonstrate functionality doing what it should do, and so on. We obviously model, but what testing does is it provides information. It's an information provision service, whether we are the developer and testing for our own benefit, or whether we're a systems tester and we provide information to stakeholders to make big decisions. At any rate, what does testing do? It provides information, it provides feedback, and that's the stabilizing effect in the system that I would say is the system development process. So if you take the technology, the development skills, the requirements, the business knowledge and understanding, the technical knowledge needed by testers, the timescales, the money, the business environment, all these things comprise a large, complex system whose goal is to deliver some kind of capability, often to a business, whether it's a corporate system or an app to sell widgets. Testing provides the feedback to steer our software development projects. So in summary, what testing is, you've seen this before if you saw the first video in this series. All testing is exploratory. We gather information, we explore our sources of knowledge. And what we do is we build mental models to basically capture our understanding, to document in our understanding in some respects. And when we are happy we know enough and we have a model that is reliable and trusted, we use that model to inform our testing, to help us to select things to test and to interpret the outcomes of our testing. So models are at the heart of problem solving, but models are at the heart of testing too. We'll look in more detail at modelling, perspective, scope and context in a modelling video a bit later on in this series.